Right, let's look at this slightly more complicated trig equation. Right, let me talk to you a little bit about what's happening here. We have 6 cos 2 theta equals minus 3. Now, what if we start with theta, what's happening is this. If we make a little function machine to see how we're going to solve this. Theta goes in. The first thing we're doing here is we're doubling it, okay? And then we're going to take cosine of whatever we have doubled, and then we're going to multiply it by 6, and then we're trying to get an output of minus 3. Okay, and then we're going to work backwards through this function machine. This is sort of a little bit about what this is, and I know it's babyish, but it kind of gives us a clear kind of step-by-step of what we're going to do. Now, what you need to remember is that cos is not a number, it's a function, right? And what it's operating on is operating on this, and I really should put a bracket around this. So we're going to do cos of this, and of this thing in total, and then we're going to multiply by 6 and we're going to get minus 3. So we're going to use the symmetry of the cos function to work out multiple answers. Now let's go ahead and try and work out what this thing in the bracket should be, okay? Alright, first of all we need to get rid of the 6 because it's multiplying everything, so we need to do cos, we need to divide both sides by 6, so cos of that bracket 2 theta is going to be minus 3 over 6, but minus 3 over 6 simplifies to minus a half. Okay, right, now what I want you to think about is this, is what we're going to do now is we're going to work out what this inside the bracket is going to come to. What should that be? Okay, what should the 2 theta equal? And the way to work that out on the calculator is we're going to do, well, we've got cos of something equals minus a half, right? Cos of this bracket, cos of something, question mark, equals a minus a half. So whatever that something is going to be cos to the minus 1 of minus a half. Okay, so let's work out what that is. Okay, so menu, let me clear all this stuff out from last time. So we're going to do, cos to the minus 1 of minus 0.5, and we get 120. So this thing here needs to be 120, all of it needs to be 120, okay? But, okay, you can probably see what we're going to do next. To work out what theta is, we're going to half that 120, so theta is going to equal 60, right? But what we're going to do is, first of all, we're going to work out multiple answers before we go and halve things, okay? We're going to try and work out other answers. So let's draw a sketch of the cosine wave, first of all. Okay, cosine wave starts at the top, loops around and back to the top. It's got a height of 1 and the lowest point is minus 1. It starts at 0, hits it here at 90, hits the lowest point at 180, and then 270, and then repeats itself at 360. Okay, now what we've just worked out is cos of something to equal minus a half is 120, right? So the something's got to be 120. So here's minus a half on our y-axis on the cos function, and if we draw a horizontal line, you can see it cuts the graph at 2 places, but there are others as well, which we'll work out in a moment. We've worked out one particular answer. We've worked out that this one here, that is 120 on our x-axis, because cos of 120 equals minus a half, right? So that's one particular answer. But using the fact that this little bit here is symmetrical, okay, from 90 to 120, that gap is a gap of 30. So if we come in 30 from 270, okay, so if we do 270 take away 30, we get 240. This is another answer as well. So this thing inside the bracket could also be 240, right? It could also be 240. So 2 theta could also be 240. But we can't just stop there because we've got multiple answers. Remember, this thing repeats every 360 degrees. So once we've got these two inside this bit, we can work out other ones. So if we do 120 add 360, okay, then what I mean by that, okay, this one here, which is also at the same height, this particular value here, is 360 away from 120. So if we add 360 to 120, well, what do we get? We get 480. Okay, so another answer for 2 theta could also be 480. So this thing inside the bracket could also be 480. And then also the same thing, if we take 240 and add 360 to it, we get the one that's over here. We get this one. Okay, we get this particular value, which would be 600. So this could also be 600. This thing inside the bracket could also be 600. So we've got lots of different answers, and I could also take away 360 if I wanted to from our original 2, and work out some negative answers if I wanted to. But let's go actually working out what theta is. So 2 theta equals all of these. Okay, it could equal that, or this, this, or this. So what could theta equal? Well, we'd have to halve each one of these, right? So if we halve these two, okay, so theta could equal 60, and a half of that is 240, so it could equal one of these, 60, 240, or we can halve this one, so that would equal 120, or it could equal half of that one, 300. So theta could be any one of these answers, or it could be some of the negative ones as well. And let's just check one of them. Let's just check 300, okay? And let's put it back into our original thing and see if we get minus 3 coming out. So let's do 6 times cos bracket 2 times 300 and see if we get minus 3 on our calculator. So let me clear all this stuff out. Okay, so we're going to do, oops, no we're not. We're going to do 6 times, then we're going to do cos 2 times 300. Press enter and we get exactly minus 3 as predicted. And all of these here, if you put it in here, you also get minus 3. Right, let's look at a slightly more complicated one than the previous one. Let's say example 4, I think we're on. 5 cos big bracket 2 theta take away 3 plus 2 equals nothing. Okay, so what we need to do is this. We need to get to a stage where we've got cos of something equals some number, and then we're going to do cos to the minus 1 of that particular number to work out what all of this in the bracket is going to equal. And then we're going to work out multiple solutions by using the symmetry of the cosine function. Okay, so first of all, how do we go about getting the cos bit on its own? We need to get rid of this 2 first of all, so we're going to subtract that minus 2 from both sides. So 0 take away 2 is going to give us a minus 2 here, and 5 cos 2 theta take away 3 is what we've ended up with here. Right, then we're going to divide both sides by 5, so we get minus 2 fifths is cos bracket 2 theta take away 3. Now, we're at the stage where we have cos of some bracket equals minus 2 fifths. So minus 2 fifths. Right, so let's work out what numbers we can have inside this bracket. So first of all, let's use the calculator to work out one of them. We need to do cos to the minus 1 of minus 2 fifths. Okay, so that's minus 0.4. So let's work that out. Cosine, okay, let's just do minus 2 divided by 5. What do we get? 113.6. Okay, so we get that this thing inside the bracket, or this thing here, 2 theta take away 3, could equal, that thing there could equal 113.6. So this could be 113.6. But we should use symmetry of the graph to find some other solutions. So let's just draw a sketch, a really horrible sketch of the cosine function. Okay, right, 90 is here, and that's 270, this is 360 where it ends, 180 is in the middle. Okay, so there should be a point there. Okay, so we have 113.6 gives us minus 2 fifths. Minus 2 fifths is here, let's say. Okay, and this particular value, this one here, is 113.6. So there's another one over here. So let's use a symmetry of the graph to try and find it. Right, what's this gap from 90? Okay, so we need to just take 90 off that to see what the gap is. 113.6 take away 90 is 23.6. So that gap there, this gap is 23.6. So let's go in that distance from 270. So 270 take away 23.6. What's that? 270 take away 23.6. It's 246.4 4. Okay, so that second solution, so this 2 theta take away 3, oh, that's really bad, take away 3 could also equal 246.3. So there's two possible things. It could equal 113.6 or 246.3, or I could keep adding 360 to this, so I could add 360 to that and get another answer, or I could add 360 to this or take away 360 to this and get negative and positive answers, and so on. Okay, so let's work out what the answer could be, so what theta could be. Right, let me rub this out first of all. Okay, so first of all, we need to do a little bit of work here. We need to add 3 first of all. So 2 theta is going to equal 106.6, and then we're going to halve that. 106.6 divided by 2. So theta could be 58.3. Okay, there's one answer. And it could also equal 2 theta take away 3 equals, what was it, 246.4. So let's add 3 to that and then divide by 2. So 2 theta could equal 249.4, and then halve that. So 249.4 divided by 2 is 124.7. Okay, right, now let's check one of the answers. Let's check this answer here in our original function. So let's do 5 times cos bracket 2 lots of 124.7 take away 3, and let's see if we get close to minus 2. Let's work that out. So 5 times cos, and in the bracket 2 times, what was the number, 124.7 take away 3 and push across, plus 2. What do we get? We get pretty close. We get minus 0.00175. Okay, it's really close to 0. It's 1 decimal place, that's 0, isn't it? And the reason why it's not exactly 0 is because we rounded this answer here, didn't we, on our calculator to 1 decimal place. If we used more decimal places, then we would have got a better answer. But so there you go. There's multiple solutions. So remember, once you worked out 2, you can just keep adding 360s and get other answers. But remember, when you get to this stage, write down multiple answers first before you go and solve it here. Okay. So before you go and do this bit, work out some other answers by using the symmetry of the graph and adding 360 and so on and so forth. And then you can go ahead and work out what the actual thing inside here has got to be. Okay, so theta is going to equal this, but this thing here inside this bit here could be 113.6 or 246 or any addition of 360 to either one of these. Okay, so using symmetry alone. Okay, so that's what you should do. Right, the next thing we're going to look at is how to, so we've got to do an example to do with the tan function because it's slightly different, and then we're going to look at how to do all of this without the calculator.